Okay, Bismillahirrahmanirrahim. Today's topic is uses of simple pendulum, and I have already listed two of the uses. The first one is determining the value of g, that is acceleration due to gravity at any place. Okay. Now, even though in our problems, numerical problems, we consider g as a constant, but in fact, actually, we know that the value of g is not constant everywhere. In the polar region, it is the value is higher, and in the equatorial region, the value is a little bit lower. Okay, so if I want to know the value of g is exactly for this place where I am standing, then I can use this formula. See, we already developed this equation last class. G is equal to 2 pi root over L by g. So I want to find out g from here. So what I will do, I will try to separate g, right? Okay. So if I take a square, it will be t square. 2 square is 4, pi square is pi square, and this root over will be gone because we took square on both the sides. Okay, then the g is divided here. If I cross multiply, it will be gt square, and then t square is multiplied, and if I change the side, it will come in the denominator. So we will get this equation. G is equal to 4 pi square L by t square. So using this equation, we can easily find out the value of g at any place. Now, what we need to know is, we already know the value of pi, we need to know the value of L and T. Now, this one actually we will do using experiment, okay? We will take a simple pendulum, we will calculate the length of the thread and the radius of the bob. So, adding those two, I will get this effective length. And then what I will do, I will, determine the time period of that simple pendulum. How I will determine the time period? Let us say I have given it a little bit of displacement. See, this is our simple pendulum, and I have given it angular displacement less than 4 degree, if you remember. So what will happen? It will have a oscillation, right? It will go here and come back. One oscillation will be completed. Again, it will go back and come back. Another oscillation will be completed. Let us say I counted 20 oscillation. How many oscillation? 20. For this 20 oscillation, I think I need to take my screen a little. Okay. So for this 20 oscillation, let us say the time was recorded 40 seconds. Okay. I calculated through the stopwatch. For this 20 oscillation, 40-second time was taken. So for one oscillation, how much time was taken? 40 divided by 20 is equal to 2 seconds. So this is the time period. The time taken to complete one oscillation is called the time period. So we have our effective length, we have our time period. So putting this value back here, I can easily calculate the acceleration due to gravity at any place on the earth. If there is any doubt in this determination process, kindly raise your hand. Okay, no worry. So we can move to our next use, that is determining the height of a mountain. Okay, we know that if we are not on the ground, okay, if we climb a mountain, the value of g is not going to be the same. Okay, so if I want to find out that one, we already know this equation for acceleration due to gravity. G is equal to gm by r square. This g is gravitational constant 6.673 into 10 to the power minus 11 Newton meter square per kg square. This one is mass of earth, and this one is radius of the earth, right? Now this radius is actually, see, means that this is the center of the earth and we are standing on the surface of the earth. So the distance will be considered as radius, right? Okay, so this is for our normal case when we are standing on the ground. But what if we climb a mountain? Okay, so let us say I am at a mountain here. Okay, so the height of the mountain is h. So what is the distance from the center now? The distance from the center is r plus h, right? So this distance r will become r plus h whole square, and the new value of g, let us consider this one to be g prime. So g prime is equal to gm by r plus h whole square. Now if I divide this equation by this one, that is g by g prime, then I can write this, right? G by gm by r square, and divided by, it becomes into, so it will be inverted. It will be r plus h whole square by gm. So gm will cancel each other. It will be r plus h by r whole square. And then if I separate it, break it, then r by r becomes 1, and then h by r becomes h by r. Okay, and then see, our target is to find out the value of h, right? So I will try to separate h slowly. So step by step. So from here my target is to remove the square, so I have to take the root over on both the sides. If I take root over in this side, square and root over will cancel each other and it will be like this, and this side there is no square, so root over will remain. So then if I take this one on that side, it will be root over g by g prime minus 1, and this r is divided here. If I cross multiply, it will be multiplied with the whole thing, right? These are simple calculations. You should be able to understand this one. Still, if there is any doubt that how this equation I have developed, you can raise your hand.
স্যার লাস্টের দুই লাইনটা একটু বুঝি নেই।
Shekha. Shekha. Irfan is talking.
আমি লাস্টের দুই লাইনটা একটু বুঝি নেই।
Oh, these two lines. Okay. See, from the g by g prime is equal to 1 plus h by r whole square. Now, if I do root over, okay, square root, if I take a square root on both the sides, it will be root over g by g prime. And the root over will be cancelled, will be balanced by the square, so it will be 1 by h by r only. 1 plus h by r only. Then what will happen? If this one is plus here, right? So if I change the side, it will be minus from this one. See, root over g by g prime, root over g by g prime. One will change the side, it will become minus. And then this r is divided, right? So if I multiply, it will be multiplied with the whole thing. Understood?
Yes.
Okay. Shekha raised hand. Okay, Shekha, I can hear you. What is your doubt?
Sir, is it determining g at any place?
At first,
There
this
are-
one, determining g at any place. Yes, this one. You have doubt in this one?
Yes, third line এর পরের দিকে একটু বুঝাই দিবেন।
Which one? This one? This third?
Third line এর পরের দিকে।
Third line এর পরে? This one?
Second এর দিকে।
Okay, okay. Now, to find out the value of g, we need two values, right? We already know the value of pi. We need the value of L and T. Now, L we can easily calculate. L is what? The length of the thread, that is small m, plus the radius of the bob. If I add these two, I will get the effective length, right? So I have the effective length. Now I need the time period. What is time period? The time needed to complete one oscillation, right? The time needed to complete one oscillation is time period. So now I will do an experiment. Okay, this experiment actually you will do in the practical of your HSC level in the science lab. Inshallah, we will be doing in the upcoming summer classes. Let me give you a little bit of idea about that. We will take a pendulum and we will give it a little displacement. Okay, then if I leave it, what will happen? It will be oscillating, right? Like that, it will be oscillating. Now, if it starts from here, it will come here and it will go back. One oscillation completed. Again, it will come, go back. Two oscillation completed. Like that, 20 oscillation we will count. Okay, it will go and come back. One, again go and come back. Two. Like that, we will count to 20. For 20 oscillation, we will record the time from our stopwatch. Okay, and from the stopwatch, let us say we found that 20 oscillation takes 40 seconds. Let us say this is just a number assumption. Okay, it might be more or less. So for 20 oscillation, it is 40 seconds. So for one oscillation, how much it will take? Definitely less. So we will divide it. Can you see the bottom of the page? This one is visible.
Yes.
Okay, so 20 will be divided, 40 divided by 20 is 2 seconds. That means for one oscillation, 2 seconds is needed. And the time needed for one oscillation is the time period, right? So we calculate the value of t, we will replace it here and we can easily find out the value of g. Any doubt?
No.
Okay, in this part, any problem?
Sir, third line এর থেকে r plus h by r square, r whole square.
Here?
Yes.
Okay, so gm and gm, they will cancel each other, right?
Yes.
So r plus h divided by r whole square. Okay, we can write it. So then R by R will become 1 and plus will be there and H by R will be there. We are breaking it up. Okay.
Okay. Okay.
Okay.
Okay.
Then root over, we take root over, the square will be gone and root over will be here, root over G by G prime. Then 1, if I change the side, it will become -1 and this R is divided here. So if I cross multiply it, it
Okay,
will be
sir.
multiplied with this one. So using this equation, we can easily find out the height of
Hi.
the mountain. Okay. Okay. Now yesterday I told you to go through the graphs that are in the books. Did you go through? I hope you did. These are very simple. Nothing complicated. Khadija, are you there? But you joined late. Okay. So we will move to the next topic. Determination of time by simple pendulum. This is one of the most important topic of this chapter. Okay. See, to determine time, we are in page 488. Page 488 at the bottom of the page. Page number 488. Okay. The topic is determination of time by simple pendulum. Determination of time by simple pendulum. Okay, let us discuss about this one. I will go through the books, okay, at the bottom of the page, okay, and check. To determine time, one type of clock is constructed with pendulum. Yes, with pendulum, one type of clock we will use. These clocks are called pendulum clock, okay. Pendulum clock is one type of second pendulum. Did I discuss about second pendulum earlier? No. Second pendulum, actually it is discussed in page number 490. Let us learn about second pendulum first. Okay, page number 490, we have second pendulum. Okay. See, second pendulum is a pendulum which takes 2 seconds to complete one oscillation. 2 seconds to complete one oscillation. That means if it starts its journey from here, it will come here, then it will reach at this point. To come from here to here, it will take 1 second and then it will go back again another 1 second. So the time period is 2 seconds. Okay. So if a pendulum is having a time period of 2 seconds, then we can say that that pendulum is the second pendulum. Okay. Second pendulum. So we know how much time this pendulum should be taking to complete one oscillation, right? We know it will take 1 second to move from this point to this point, and then another 1 second to come from this point to this point. So total 2 seconds will be required to complete one oscillation, and to complete one oscillation, the time required is called time period. So the time period will be 2 seconds. So in the definition, you can write if the time period of a pendulum is 2 seconds, then that pendulum is called second pendulum. Okay, so we can come back to our topic again, 488 page. Okay, pendulum clock is one type of second pendulum, that is its time period is 2 seconds. Yes, this is what we just learned. Its half time period is 1 second. Half time period is t, then half time period means t by 2, that is obviously 2 by 2 is 1 second. It makes one tick or beat in every one half oscillation. That means when it comes from here to here, one tick, another tick. So in one time period, we will hear two tick. Okay, two tick. Okay, in every half oscillation in 1 second. Achha. Generally, these pendulums are made of metallic material. The length of the pendulum changes with the change of temperature. The length of the pendulum changes with the change of temperature. Hence, the time period also changes. For this clock, the clock runs either fast or slow. Yes, we know that if the temperature increases, the metal or any substance increases in length, right? So if the length of the thread increases, so definitely it will be affecting the time period. Why? Because if the length of the thread increases, the effective length will change, right? So if the effective length is changing, we know that the value will affect the time period. If L is changing or G is changing, then it will affect the time period T. Okay, so either it will become fast or slow. Okay, controlling the screw attached to the bottom of the bob, the time period is adjusted since 1 day is 86,400 seconds. We know that 1 day is equal to 24 hours and 1 hour is equal to 60 minutes and 1 minute equal to 60 seconds. So if I convert 1 day to second, then I will see that it will be 86,400 like this. 1 day is equal to 24 hour. 24 hour if I convert into minute, it will be into 60. Okay, minute, and if I want to convert it into second, I will multiply by another 60. So this one. So you can check in your calculator. If you multiply all this, do you get 80 or 86,400 seconds or not? Okay. Acha. Hence, a pendulum clock showing correct time performs 86,400 half oscillations in 1 day. This is very true. Okay. In 1 second, one half oscillation. 1 second, it will do one half oscillation. Half oscillation means it will come from here to here, right? Half oscillation. So if I have 86,400 seconds, in that time, it will complete equal number of half oscillation, right? Okay, half oscillation we are talking about. Do not get confused. Okay. Then what is happening? If the pendulum clock runs fast or slow, then the time period is determined in this following way. See, let the pendulum clock runs n seconds slow in a day. Suppose we got to know that this pendulum is running slow. Okay, so how many times slow? N seconds slow in a day. Then the pendulum will perform 86,400 minus n half oscillation. I will erase the board and explain this one. So it is running n seconds slow. If you run slow, definitely you will cover less amount of distance. And for this one, if it is going slow, then it will complete less oscillations, right? So previously, it used to complete 86,400 oscillation, half oscillation, 86,400 half oscillation per day. But now it is running n seconds slow. So that number of half oscillation will be subtracted because it is going slow now. So it will complete less amount of half oscillations. Okay. Now the pendulum performs one half oscillation. Okay. Pendulum performs. Okay. This one to perform this oscillation, it will take 86,400 seconds. For one half oscillation, we are talking about half oscillation. Okay, let me put it in this way, shortcut. Okay, it will take time. 86,400 divided by 86,400 minus n. Okay, now the pendulum performs two half oscillation. So for two half oscillation means one complete oscillation. So it will be 2 into 86,400 minus n. Till now, if you have any doubt, kindly raise your hand because I'm guessing that this part might be a little bit of confusing. I'm going to explain if you raise your hand.
So
Khadija.
two half oscillation means one full oscillation, right?
Yes, yes. I will
Then
listen to
one
everyone. Okay, wait. Let me hear to Khadija first. Khadija, কি সমস্যা বলো?
স্যার আমরা সেকেন্ডস গুলো এসব বাই করছি, আমি কিছু বুঝতেছি না।
হ্যাঁ, বুঝি নাই।
বুঝতেছি না কিছু।
কোনটা?
ওই যে মিন্স এই পার্টটাই 86,400 সেকেন্ড এগুলো
আচ্ছা,
কেন?
ঠিক আছে, কোনো সমস্যা নাই। I will explain again. See, we know that this is a second pendulum. Okay, so for half oscillation, it will take 1 second. এই লাইনটাতে কোনো ডাউট আছে?
না।
ওকে, ফাইন। তাইলে এখন দেখো 1 ডে তে কত সেকেন্ড? 86,400 সেকেন্ড 1 ডে তে। তো 1 সেকেন্ডে যদি হাফ অসিলেশন কমপ্লিট করে তাহলে 86400 সেকেন্ডে 86400 হাফ অসিলেশন কমপ্লিট করবে। Understood? Now the clock is running slow. Let us say the pendulum is running slow. Then what will happen? It will complete less amount of oscillation in the same time. We will take the time 1 day. But now as it is running slow, it will complete less oscillation, right? So the time is taken, the time taken will be 86400 only, but the oscillation completed, half oscillation completed will be less. Previously it was 86400 because it was running correctly, but now it is running slow, so less amount of half oscillation will be completed. Okay?
Yes. Yeah.
Now this amount of half oscillation is completed in this amount of time. So one half oscillation is completed in this amount of time, so it will be divided here. Now two half oscillation will be completed in double amount of time, right? One half oscillation, this one, two half oscillation, two into this one, double. Now two half oscillations mean one complete oscillation. Do you understand this one? One half oscillation, another half oscillation, so one complete oscillation. Is this part clear? If there is any doubt, please tell me. No problem. I will discuss again. I understand this one is a little bit confusing. Should I explain again?
Okay.
সমস্যা থাকলে বলো, আমি তো বুঝতেছি তোমাদের কোনো সমস্যা থাকলে থাকতে পারে। কোন পার্ট? এই লাইনটা বোঝা নাই? এই যে এটা কেন এরকম হচ্ছে?
হ্যাঁ, এই লাইনটাই।
এই লাইনটাই বোঝা নাই। ওকে, আমি আবার বলতেছি, দেখো যখন ক্লকটা ঠিকঠাক চলতেছিল তখনের কথা চিন্তা করো, 86400 হাফ অসিলেশন কমপ্লিট করতেছে 86400 সেকেন্ডে। ক্লিয়ার এটা? ক্লকটা ঠিক চলতেছে, 1 সেকেন্ডে একটা হাফ অসিলেশন, তাইলে এত সেকেন্ডে এতটাই হাফ অসিলেশন কমপ্লিট হবে। নাও দ্য ক্লক ইজ রানিং স্লো, ও n সেকেন্ড স্লো চলতেছে, ঠিক আছে? দেন হোয়াট উইল হ্যাপেন? এটা কম নাম্বার অফ অসিলেশন কমপ্লিট করবে না। তুমি দেখো যদি ফাস্ট চলতো তাহলে বেশি নাম্বার অফ অসিলেশন কমপ্লিট করতো, বাট যেহেতু স্লো চলতেছে আগে যতটুকু হাফ অসিলেশন কমপ্লিট করতে হবে তার থেকে কম করবে না।
হ্যাঁ,
তো তাইলে যত সেকেন্ড স্লো চলে তত সেকেন্ড আমরা এখান থেকে মাইনাস করে দিব না?
হ্যাঁ।
তো তাইলে 86400 মাইনাস n, এতগুলা হাফ অসিলেশন ও কমপ্লিট করবে, টাইম সেম নিবে। কি বলতেছি বুঝতে পারছো? টাইম আমরা একদিনই দেখব, আগে একদিনে 86400 ই করতো, এখন আমরা একদিন নিচ্ছি, কিন্তু ও স্লো চলার কারণে ও কিছু কম অসিলেশন কমপ্লিট করতেছে। ক্লিয়ার?
ইয়া।
ওকে, তো এটা যদি এতগুলো হাফ অসিলেশনের জন্য এত টাইম লাগে, তাহলে একটা হাফ অসিলেশনের জন্য কত টাইম লাগবে?
তো ডিভাইড হবে। ওকে স্যার, এখন বুঝছি।
ঠিক আছে? 86400 মাইনাস n। তো তারপরে দুইটা অসিলেশনের জন্য এটার সাথে জাস্ট 2 মাল্টিপ্লাই করে দিব, তাই না? দুইটা যদি লিখি ইনটু 2, এই এতটুকু, এটাই এখন পর্যন্ত এতটুকুই করছি আমরা। কোনো সমস্যা আছে এখন?
না স্যার, না।
আচ্ছা ঠিক আছে, ওকে। দেন আর কে জানে হাত তুলছিল? জামান, কিছু বলবা জামান?
না স্যার, না।
Okay, good. Now we can proceed, I guess. Okay. Okay, so kindly take a look. See, if it runs n seconds slow in one day, then time period will be, see, we have taken this one. Oh, acha, 86, one half oscillation and two half oscillation. Now two half oscillation means one oscillation, right? One oscillation. So one oscillation, it will take this amount of time. So this is our time period now, because the time taken to complete one oscillation is time period, right? So this is our time period. If it is running n seconds slow. Acha. So then what is happening? If it runs n seconds slow in one day, then its time period will be 2 into 86400 divided by 86400 minus n. Oh, we have less than 10 minutes again. Okay, fine. Then again, if the pendulum runs n seconds fast in a day, now you are running faster, so you will be able to complete more oscillations, right? So the difference, the only difference in case of slow, if I write fast, it will be plus only, no other changes, right? And here also it will be plus, it will be plus. So if it is running fast, then the time period will be this one. Okay, so see, we can calculate the time period using a simple pendulum, second pendulum. Is there any doubt in this equation now? If there is
No.
doubt, kindly raise your hand. Baby Hawa, Baby Hawa, দুইটা কই থেকে আসলো? Baby Hawa, I can see your name twice. What is the
না
God?
স্যার একটাই তো
Oh, আমার এখানে দুইটা দেখাচ্ছে। আচ্ছা যাই হোক। Any doubt? Anybody have any doubt? No, I guess. Okay, thank you. Now, few phenomena regarding pendulum clock. When a pendulum clock is taken on a mountain, these things are actually, examples. Kindly go through these examples and let me know if you have any doubt in the next class. And as I told you already, actually I'm taking the class in multi-purpose room, and many teachers want to take class here. That's why I'm having to leave the room for them. Okay. But inshallah, what I will try to do is, see, on Tuesday and Monday, Tuesday, we don't have any class, right? So I will try to take one class at least on those days. Okay. So I will let you know if I can manage a class, or you can also let me know if any teacher is not taking any class on that day. So I can, if I'm free that period, I can take your class. Okay. Okay. Now kindly see, only the one topic is left. Bolo.
স্যার বাংলা ক্লাস তো হয় না।
বাংলা ক্লাস হয় না, তাহলে বাংলা ক্লাস এই যে মানডে আর টুয়েসডে তে কোন পিরিয়ডে, এটা একটু আমাকে তোমরা মেসেজ করিও, ঠিক আছে? তাইলে আমি ওই পিরিয়ডে ক্লাস নিব। নাকি আবার দেখা যাবে নেক্সট উইক থেকে বাংলা ক্লাস নিয়ে শুরু করে দিয়েছে। আচ্ছা, whatever it is, keep me updated, okay? Then we can make some arrangement and we can clear. Only one topic left. See, the two topics. Second pendulum, I discussed just the definition. Go through the calculation also. I think you will understand the calculation now. Time period is 2 seconds, so they just replaced 2 in place of t, and the later all the things are similar. Okay, relation between simple harmonic motion and circular motion. Simple harmonic motion and circular motion, they are closely related. Okay, I will explain this one inshallah next class, but it will be better for you if you go through this part beforehand, so that you are prepared, your mind is prepared. Okay, if you have read this once at least, then when I explain, it will be easier for you to understand. Okay, so inshallah next class we will be finishing this one, and in the meantime what you can do, see, this is a weekend coming up, right? So in this weekend what you can do, practice the numerical problems of this chapter, and also solve the creatives of the suggestion book. Okay, so if you keep doing that, you can ask me doubt on Sunday. Okay, I hope that's okay. So inshallah we will meet on Sunday, and the last topic, go through yourself. If any doubt, I will explain inshallah. Okay, thank you very much. Assalamu alaikum.